Hi, it's John Williams here at MIT, and today we're talking about security essentials. And the rudiments of security consist of user-level security and code-level security, or code access security, sometimes abbreviated to CAS. So user-level security is needed by every system. So we typically need a username and password to log in. So that process is called identification. So when we give the name, our name and password, that system identifies us. Now linked to our identity is something called an access control list. And that gives us authorization to do certain things on certain programs. So it gives us access to certain programs. For example, we might have an ERP system, and then it determines what we can do with that software. Now, today we're going to focus on this second one, this code access security or code level security. So similarly, we need to identify pieces of code, often called assemblies in .NET, that do certain things, and we need to assign them permissions and restrict what they can do. So let's take a look. So software often uses libraries and other applications, and when we load a library into our program, we may want to restrict what that library can do. For example, we may want to stop it reading and writing to our file system. That's a typical thing that we want to do. Now in .NET, we can restrict the functionality of assemblies. So these are just pieces of code, as you all know. And we enforce security policies by preventing those assemblies from accessing, for example, infrastructure such as the operating system functionality to read and write to the disk. So we restrict what the code can do. We restrict what code can be called by your code. And the assemblies are identified uniquely. So typically they're signed. In .NET, this is a diagram of the security policy structure. So there are policies at the enterprise level, at the machine level, and at the user level. Now, browsers use a policy called sandboxing, or rather a technique called. Now, browsers use a technique called sandboxing. And for example, in Internet Explorer, after IE10, there's an enhanced protection mode. And basically that places the Internet Explorer process in a sandbox that restricts both read and write access and also provides certain other processes from performing operations, again, that we want to restrict. And the same concepts apply in the Linux domain, such as SE Linux, and often you'll find in virtual machines that they're put in what's called a jail that stops those virtual machines, for example, accessing the network. So sandboxing is a very important security technique. It's used by all the browsers. Viruses sometimes can break out of these sandboxes. So for example, Chrome is roughly 20 million lines of code, and it loads up other plugins that are not authored by Google, and so it's very difficult to make this sandbox watertight. And sandboxing today is used throughout the industry for limiting what processes can do. So thanks very much, and we'll be back shortly with another video.